Hello all, we are going to see about this linear transformation today. So all have to know about it is T is a linear transformation from vector space V to W is another vector space. So T is said to be a linear if these two conditions are getting satisfied. That is T of h plus y equal to T of h plus T of y, and T of ch is equal to C times T of h. That's x and y are the elements of the transformations. So x and y are the element of the domain, that is V. When you add them again, it will be in V. So when you transform them, it has to go to T of x. That is T of x is in W and T of y will be again in W. So these two conditions should be satisfied in order to be a linear. Now we are going to see this linear transformation in a point of examination. Now we are going to see about linear transformation from the examination point of view. So if T is linear, then T of 0 is equal to 0. Here this 0 is from V and 0 is from W. This 0 is from W. So T is linear, then it should satisfy. But if it is satisfying, then T need not to be a linear. So it is if and then. Now if T is linear, if and only, if T, you cannot say. So T is linear if and only if T of Ch plus is equal to Cth plus T of y. So we are just combining these two equations. So if you are combining these two equation in one, you have to write in this way, and that C has to be separated. So T of Ch plus y is equal to C of Th plus T of y. So this is a if and only if case. So if it is satisfying, it will be linear, or if it is linear, then it is obviously satisfying. So then if T is linear, then T of x minus y is equal to T of x minus T of y. So this is if and then case. Again, if and only if case. T is linear if and only if for h1 to hn in V, that is we are taking from domain, and a1 to an is in the field, we have T of summation ai hi. So we are just writing this ch plus y in terms of n variables. So n vectors. Okay, so ai hi, that is ch, c1h, c2h till cnh, right? So that is you are writing it as ai hi, a1h1 plus a2hn till anhn. So you are writing in this way, and it has to be satisfying summation ai t hi. So for two vectors it would be like this, and for n vectors it would be like this, and hence if it is satisfying, then it will be a T is linear. If it is linear also, this condition gets satisfied. So this is the difference between if and only if and if and then cases. So these are all the basics that you should know before going for the linear transformation in detail. We are going to see let T is from B to W be linear if beta is the containing the set of all V1 to Vn is a basis for V. So this is the basis for V. Then range space of T. Range space of T will be in W, right? The range space of T is equal to spanning set of transformation of the beta elements. That is spanning set of T of V1, T of V2 till T of Vn. So R of T will contain the spanning set of the respective basis transformations. So this is a theorem. Another one, let T is from V to W be linear. So they are given linear. They are asking V and W are finite dimension vector space of equal dimension. So they are given V and W to be equal dimension. So you can't ask me why T is from V to V, it is from V to W. So there are some vector spaces which have equal dimension and which are not equal in such a case. Like we can take P2 of R. So P2 of R, the dimension will polynomial of over the real number. So the dimension will be 3 and R3 will be V. So we're taking V is equal to R3 and W is equal to P2 of R. The dimensions are same, but they are not equal vector spaces. Okay, so we are taking T from V to W of equal dimension. So these following are equivalent. So if it is T is 1 1, then it is T is on 2. Rank of T equal dimension of V. So one is satisfied, other things are satisfied. Either one have to be satisfied, then other two are automatically get satisfied. Okay, so this means the following are equivalent in the sense 1 implies 2, 2 implies 3, and 3 implies 1. So everything in this way it goes on in a chain. Okay, you have to take it in a combination. Now we are going to see these 5 questions. We have to tell whether it is a true or false. Take a transformation from T which is from V to W. So first question is, if t is linear, then t of 0v. 0v is a notation for 0 vector from the vector space v. So 0v will be going for the 0w. Say whether it is a true or false. Yes, it is true, because you have to know this is the definition that we have seen recently. So 0v will always transforms this 0 vector to 0 vector in w. Next question, which is similar to this, but you have to know the difference between these two things. T is 1 1, so you should not write if over here. Okay, t is 1 1 if and only if the only vector h such that t of h is equal to 0 is h is equal to 0. So they are saying t of h is equal to 0 will be satisfied by only the vector h is equal to 0. That means t of 0 only becomes 0 and no other vector will gives you 0. So they are giving this condition, that is this condition, but they are telling t is 1 1. It is not telling, they are not telling as t is linear. So t is 1 1 if and only if the only vector t of h is equal to 0 is h is equal to 0. So this is false statement. So you can take a case. Okay, you can take this case, t of h is equal to h plus 1. Now for the third one, we have if t and u are the two transformation which is from v to w, both linear. So they are telling t is a transformation from v to w and u is a transformation from v to w, and they are saying this both are linear and agree a basis for v. Agree a basis for v means they have the basis for v. The basis properties which were all we have discussed earlier will be satisfied over here. So then they are asking t is equal to u. So they both have the basis for v. So then they are telling t is equal to u. The transformation for t and u are the same, because the basis for because they both have the basis, and this has the answer to be true. Now other question, given h1 and h2 belongs to v, y1 and y2 belongs to w, there exists a linear transformation from t, that is v to w, such that t of h1 equal to y1, t of h2 equal to y2. So they are taking h1 and h2 from the vector space v. Okay, let us take in this way, that is the transformation from h1 h2 from v and y1 y2 from w. So they are given h1 h2 from v and y1 y2 from w. There exists a linear transformation such that t of h1 will goes to y1 and transformation of h2 goes to y2. So we have to construct in that way in order to satisfy these two conditions. Okay, so if there is any transformation is quite possible or not. So this is the question. We might think we can construct in such a way that these two conditions get satisfied, but the answer for this question is false. That is taking h2 is equal to 2 times h1. Okay, so t of h2 becomes t of 2 times h1, which is equal to 2 times t of h1, which will gives you 2 times y1, which is not equal. So they have given for every h1 h2 in v and y1 y2 in w, there exists a linear transformation such that these two conditions get satisfied. Okay, so they are fixing this h1 h2 y1 y2 as well, and then they are refining this transformation. But for if this is not a transformation, which this is, we are fixing that h2 and h1 relation, so that there will be y1 y2 relation also should have to be satisfied. So we cannot, there exists linear transformation, so they are giving there exists a linear transformation. So obviously most of the people would have say this is true, but this is false, because they are fixing that y1 y2, but we can take h1 and h2 in such a case that h2 to be equal to 2h1, so that y1 y2 will also should have to be become dependent on each other, because the transformation, after transformation, this y2 becomes 2y1. But if you are getting y1 and y2 without any relation, that is y1 and y2 as linear independent, then there won't be any transformation existing. So this, according to this this option is again false. Question, if t is linear, then t carries a linear independent subset of v onto the linear independent subset of w. So it is carrying a linear independent subset of v onto the linear independent subset of w. So in mostly we will think it is a linear, so it will be satisfying, but you have to say that we can take up the null space. Null space will carry all this all the vectors from the v to 0, but 0 is obviously it's not a linearly independent. So in that way we can define this is a false statement. So this is about a linear transformation introduction. So if you have any doubts, you can ask me in the comment section. Thanks for watching.